My channel videos. Okay. Let me send out the link. Hide this really quickly. Oh God. Uh-huh. Let me see if that propagated. Yes, okay. As I send out a link to this, I'm going to tweet the link. Share, copy this link. Uh-huh. I'm streaming, see if that propagated. Colon, paste. Yes, okay. As I send out a link to, okay, this, I'm going to tweet the link. Share, copy this link. Okay, so what we're doing in this stream, what I'm doing, is I'm trying to write a self-hosted compiler. I got the edge, and I want to keep it as simple as possible. I want to be able to, like, as quickly as possible, get to self-hosted. And I think the best way to do that is to just completely reuse C as the base. And so the language is going to be very, very similar. It's going to be identical to C at first. And then I will slowly add tiny little features until it's different from C. Just, I think that's, and I think you can take C as your base and then like, and add features, and eventually it will become its own language. Like I think that's a valid way to do things. I just want to try this as the starting point. I think that's interesting. So I have, oh, I'm calling it Parasitic C. That's the name of the language. Parasitic C, because it's going to sort of eat the C language from the inside out. I think that's fun. So the first thing I need to do is basically write a parser in C for C. And parsing is always the least fun part of a compiler, in my opinion. And I usually use a what's it called, a parser combinator library when I'm doing parsing, because that's how I think about it. But obviously, you can't really do that in C, so I'm gonna have to do. I'm gonna have to probably do like a recursive descent parser. So, and I kind of forget how to do them. All right, let's try void parse. And actually, maybe we should do tokenization first. Oh boy. All right, so enum token. And we'll have, okay, it could be a keyword. Do I need to do like, like this. A keyword, it could have a number, an int. Let's just try to get it like this. So I could have a token include for this part up here. We'll just, I don't know, keep that as a token. Or maybe it should be hash, token hash, pound, pound. It could be have string literal. Levi. What? Levi, I'm streaming. Oh. Come on. There's no camera.
Hell yeah. There's like a microphone?
Yeah, there's a microphone.
Okay. Whew.
I'm writing a self-hosted compiler in C, and it's gonna, oh well, this is sort of complicated, but
okay.
I got the edge. Where was I? Oh yeah. String literal token open paren and close paren and brace. Open and close brace. Is this how you define a enum? Do I need commas here? And semicolon at the end. Oh my god, I don't even know C. Okay. In fact, maybe we shouldn't be using enums because that is too complicated. So let's just do this as constants. Const. How do I do this? Int equals 0, like this? Is that valid? Int equals 1 equals 2 equals 3 equals 4 equals 5 and equals 6. Okay. Maybe instead of keyword, we should just do like list out the keywords. Oh god. Okay. Maybe not. No, we should. Okay. So let's do. We need the int type. We need void type. Let's leave it at this for now. In fact, let's move all of these down to the bottom. Ugh, this is so. Ugh, I hate this. 1, 2, 3, 4, 5, 6, 7, and while we're here, I'm probably going to need brackets and commas and semicolons. Semicolons definitely. Am I gonna need commas? Semi. I mean comments, but we're basically just gonna skip comments for now, so I think that's okay. Okay, I think that's everything that we need for this program at least. Oh, well, okay, not these down here though. So we need ints and like int literals, string literals. So this should be int literal, and we're also going to need equal sign, semi, and equal equal sign. Okay, now we should go through and renumber all of these. Ugh, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is tedious. 13. It's almost worth it to have enums from the start. Oh well. Oh well. Okay. We also need identifiers. That's the other thing we need. Int token ident equals 14. Okay. Now let's write the lexer. We can close that. The lexer. So a lexer takes in a string, and I think usually the way it works is you have like some static state, or I don't know, maybe you repeatedly call it. I'd rather do it in a more functional way than like with statics, like you probably should in C. I think like strtoc in C does it so that like every time you call it, even if you use the same arguments or something, you like set it up first and then you call it repeatedly, and it's just like weird and kind of hides the state. So I'd rather do it in a more functional way where the state is obvious. So we're just gonna say, I don't know, void lex. Lex accepts a string and chomps the next token and returns the token type and the new string position. All right, so I don't know how to return two things in C. I guess I have to do like out parameters. So, all right, we want a char pointer to constant characters. This is going to be called input. And then we want, oh dear, okay. And we want, is this like already a new prototype parameter? No, whatever. It needs to return the token type and the new string position. Okay, so these are both going to be out parameters. Kind of like, it's going to return the token type, which is going to be an int. Out token. Oh, if it's an out parameter, I'll just prefix it with the word out. And if it's an out parameter, it needs to be a pointer. And we need a char. Am I doing these consts right? I should probably just not use const for right now. Let me just get it like compiling. Okay, character, pointer, pointer. Or no, just character pointer. Out. I don't know. New position. New input. Okay. All right. And I don't know, maybe it should return an int. Nah, we'll just exit the program if there's like an error. Okay, so okay. How do you do lexing in C? How do you do lexing in C? So we want to say I need like a starts with function. Starts with and oh god, how do I do this? So complicated. Starts with char pointer input, char pointer target, and we're gonna say, I'm sure there's a way to do this with like some library function, but I should write it myself because it's gonna have to be self-hosted. So okay, so we're gonna say for an I equals 0 while input I is not null, so I can just do that, and target I is not null. We're going to do I++. And get ready for some bad C formatting. Ugh. Okay. Because what I want to do is actually expand this. And so keep going until you hit either a null input, which I might as well just write this, not equal to the null character, and target is not equal to the null. The null character, and Um, what else? What else? Um, Diana in the chat is saying 0 out of 10, not enough Rust. Yeah. So I was thinking about Rust, about using Rust. I just didn't want to deal with like uh, generating Rust and getting like a whole bunch of errors and warnings and all this because Rust, once you just do it in a good way, I want to have the freedom to like generate absolutely horrible C, um, because C is going to be the target language as well. Uh, so eventually, it's going to be a compiler for a language that looks identical to C. I mean, this is the first step of bootstrapping for this language. It's going to be a compiler that takes in C code, some subset of C code it understands, and then basically just spits that C out again. But it's going to be like completely unformatted and potentially just like on one line, like generated JavaScript or something. And it's going to look absolutely horrible. And we're going to feed that into the C compiler, and and then it'll generate an executable for you. And I was worried that like Rust would just like be throwing a whole bunch of like very reasonable errors at me for doing this very horrible thing. So I thought I might as well use C. And actually, for the C compiler that I'm going to be using to compile this, so like you have to call into like GCC or something, but I'm not going to use GCC. I'm going to use Zig as the compiler. So that's what I'm using down here. I'm just using ZigCC because this is on Windows and I don't know how to compile stuff on Windows and I happen to have Zig installed and it comes with a C compiler. So that, that's what we're going to do. This is just because that's going to make it easier for me. So um, there's still time to do it. The errors will help the C version. The errors will help. The C version will mysteriously fail. Yes. What does parasitic mean, by the way? I'm calling it parasitic C because it's going to sort of like a parasite is going to start eating its host from the inside out. So the language initially is going to look identical to C or identical to a subset of C. And then once we get it self-hosting, which is just going to like spit out the exact same code that it reads in, then we'll add features and be like, oh, you can, I don't know, have like a new keyword that's like, I don't know, match, maybe the match statement from Rust. Um, and you just add that in. So now it's C, but it has this one extra feature. And eventually it'll be its own language. So we're going to try to eat C from the inside out and turn it into this parasitized, uh, I don't know, like mad cow disease or whatever, where the fungus like takes over a cow's brain, or is that an ant's brain? It's gonna be like that. So that's why I'm calling it parasitic C. All right, but first I have to parse C in C, which is not gonna be super fun. So that's what we're doing right now. Okay, so keep going. This is starts with. All right, so we're comparing the input string to a target string, and we're going to say, does the input start with a target string? So we're going to keep going until either of these is null, and we're going to break out if input I is not equal to target I. No, we got to keep going while that's the case. What? You just gonna sneeze?
Yeah, basically.
Okay.
No, I'm just here to hang out.
Okay. Um, I feel like this should be inside here. I think we should just do it in a dumb way instead of trying to be clever. Okay, so we definitely want to break out if either of these becomes null. Um, and we want to say, okay, we got to break out and return false if the two characters are different. So return false. I have to include this. Here's what we're going to do. Int false equals 0. True equals 1. All right. I don't want to include standard bool or whatever, so. All right, so that's definitely true. We break out of this loop if they're not equal. What happens if input still has stuff in it, but target is null? That's actually okay, because we're doing starts with. So if the input string still has stuff in it, then this is false, so we're going to continue in the loop. But this is empty. I mean, maybe we should just move this test down into the loop body. So this becomes like a while loop. That makes sense. While, and then we gotta move this up. And then we gotta move this down. I plus plus, and then we gotta move this, I don't know, down here somewhere. And then we gotta do while true. Ugh. Okay, then we're gonna say, all right, one way to exit with false is if at any point the two strings are not equal. Okay, but it's actually okay if they're different, but one of them is null and the other's not. Which one is which though? Okay, if the input is longer than the target and the target is done. Okay, so if target is null, we're done with target, but input is not null, then we can return true at that point. We can return true at that point. If the target is at its end, but the input is not at its end, we can return true. Or if the input is at its end. So I guess it doesn't matter what this is. If you get to the end of the target string, then we can return true. Ugh, okay, the auto formatter. Okay. If otherwise, if at any point the input is not the same as the target character, the input character is not the same as the target character, then you gotta return false, because that means it's not a subset. Or, yeah. Okay. Is that it? Okay, how do I test this? Where's main? Why is main up here? Let's move main down here. And we're gonna say starts with the input is going to be int main blah blah blah. How about that? And the target is going to be int. And we're going to say int result equals this. And then we're going to say %d result equals %d result. And now we're going to run this. All right. One warning generated. Okay. Result equals true. That's good. If this is an empty string, this should also return true. Yeah. No, it's not. Okay. Why does it not return true? Starts with empty string. If this starts with the empty string, it should return true. Oh, should this be like equals instead of not equals? If the target is that, oh yeah, okay. Okay, that's correct. Let's try this again. Result is true. Okay, and then if we delete all this, and we say, does this start with int? That should return false, right? Result equals false. Yeah, okay. So it seems like it's working. All right. And I think we're done. I mean, I guess in the case where neither of these have 0 are null terminated, we could probably get stuck in an infinite loop, but whatever. All right, so now we have starts with. So let's try using it. If starts with input, and we should probably also return, or not return, but have an out parameter that says how far we got in the string. So return false, return true. We should say, we should have an out parameter, which is a char pointer new input, and that's an out parameter. We should, this needs to be a pointer to a pointer, right? Because it needs to be modified. Is that how you do this? New input, star new input equals input plus I. Let's see if this works. In fact, that's fine. But okay, if this is not the case, then we should not set the new input. So star new input should just equal input here. Okay, because if it fails, if any of the characters are not equal, then we should reset the input. So the new input is reset. Okay. All right. All right, so starts with input. Let's say starts with, what's my first thing? Pound. Hashtag. We want to say pass in the memory address of the input variable, and that will be our output. Okay, so that'll update. That'll be our new input. Okay, so if it starts with pound, then out token is going to equal token pound return. New input. Huh. Okay. Star new input equals input, because input is a local variable and it keeps getting modified. And then we need to set it to this, set the output variable to this before we return. I don't know, maybe there's a better way to do that. Okay, so that's one case. So there's just going to be a whole bunch of these cases. If starts with okay, let's do an error case and then test it. So if it gets to all the way to the end, we wanna, how do I p error and standard iota h an error message unrecognized token exit with 1 exit file Parasitic. What? Exit is not defined here. What are you talking about? Okay. I think I need to include like what, where is exit defined? Where is exit defined? See exit. Probably standard lib. Following. I do not like this website. CPP exit. Define as standard lib.h. Okay. Pound include standard lib.h exit printf as well as, was I using p error? Okay. All right, let's test it out. So main, we're going to say lex. Input is going to be int main, or actually, we're going to say pound include. That'll be our first test. And our output token, we're going to have int out toke equals, I don't know, whatever, negative, blah, blah, blah. And we need a new input, char pointer, new input equals blah, blah, blah. Okay. So we want to reference out token, and we want to reference new input mutably. All right, and then we need to see what we got. So printf, okay, out token equals %d. I should expect pound. So let's do toke pound equals %d. new line, and then we want to say out toke and toke pound. And then we want to say new input equals %s. And we don't need this. Let's put some braces around it so we can see what it is. New input. Delete word, delete word. Okay. Let's run it. What? Excuse me. Oh, it's running the previous version. Okay. Okay. Implicit declaration of function lex. Oh, great. Right, because this comes after, so I do need like main at the end. Well, let's try it again. How do I do ampersand in? Hey, okay, so I think it's working. New input equals include. Yeah. Maybe instead of this, we should do quote marks. Nice. Okay, and then let's test if we have, I don't know, exclamation point. Let's run it again, and we should get an error. Unrecognized token, no error. Okay, I completely forget how to how to use p error. Let me look that up real quick. C p error. P error. Yeah, you send it a message. Oh, and it's printing out like error no. Notation followed by a new line. Description is formed by concatenating the following components. Okay, so it takes in a message, then it puts in colon space. Unless S is a null pointer or the character pointer, when it's defined by null character implementation, define error message describing the error code stored in error now. Okay. Okay. The error message string is identical to the result of stir error now. Error now. I don't know. Is there? These are all the error now values, I think. Define in POSIX. Okay, I'm probably not going to use these. Whatever. All right, let's not worry about that. So it says no error. Whatever. Okay. Let me just test instead of semicolon. I want to try. Oops. I want to try ampersand, like in Unix. No, it does not know about that. In PowerShell, I have no idea how to do the equivalent of ampersand. Oh well. Okay, so that seems to be working. Let's continue. So now I can start just doing a whole bunch of these, like a big chain of these. If it starts with string literals, ugh, I don't want to do string literals. Let's do the easy ones. Int literals, open paren, close paren. Let's do open close. Let's do the parentheses. Where am I? if it starts with open paren, then we want toke open paren. This is going to be repetitive. Is there a better way to do this? I can make it macro. Oh God. Let's keep it simple. Close paren. Close paren. Open brace. Brace. Close brace. Brace. Yank. I'm trying to write really simple C because everything you write, every piece of code here needs to be translatable, or needs to be parsed and handled by the compiler that I'm writing because it's going to be self-hosted. So you have to keep it like pretty like basic. Okay. And I'm probably already not doing a great job of that. Okay, bracket and bracket. What other tokens are there? String literals, int literals. Okay, I have all of these. Let me put some semicolon equals int void ident. I mean, we're gonna want char in here, right? Char 14 15. We're gonna want star for pointers. 12. Whoa, where did I just go? 12, 13, 14, 15, 16. Okay. Semi equal star and void char ident. Okay. So let's do those. Semi equal star. Yank. Semicolon. Semi. This is just dead simple. Yank. Paste. Semicolon. Equal. Equal. Yank. Paste. Star. Star. Okay. You know what? I mean, this should just be the out parameter, right? No, I guess you do want like a separate thing. All right. Okay. We have star. We need int void char. yank. I'm not using those nice Vim buffers. I could be doing that. I'm just not good enough. Int. Void. Oops, it's not capitalized up here. Void. And really, we probably need to be testing that, like, the next character is, like, white space. Char. Okay. And then there's going to be ident, right? Down here. Okay, so let's figure out, do any other ones of these require white space after them? No. Okay, these are all like special characters. So int, we need to do a look ahead. Look ahead is white space. I think there's is space. How do I do this? C is space. C is space. Is space. This is defined in what the hell is this website? C is space function. Define ctype.h header file. Do I want to include that? Why don't I just write my own isSpace function? IsSpace. Input. If, actually, this should just be up here, right? Oh, I'm anticipating a problem. Okay, if we get to this point, all right, hang on. Let me quickly write isSpace. Int isSpace. Take in a char pointer s, and we want to say star s equals space or star s equals new line or star s equals tab. Anything else? That's probably good for now. Yeah, okay. Okay. So now we gotta think about this. We gotta do like a look ahead. How do I do this? So we've already updated input. We've advanced input. at this point. But I still need a way to like skip out. Okay, well, that's going to be an if condition, right? So just an if inside of an if. But, okay, we're going to say if is space input, then you do this. So that's good. Um, and honestly, this should sort of have the same format as this. It should have like, should update input as well. And it should allow multiple spaces. So expect space input ref input. Yeah. Otherwise, we need to like go back to the to what input was at the beginning of this, right? So I guess at like the top of this, we need to save old input, char pointer old input equals input, so that we can go back to it. So input equals old input, and then like continue. Oh God. Okay. So expect space. Now I need to go here. What, that doesn't work. Oh, right, because I didn't define it. Expect space. Input and char pointer pointer new input. So this is going to be more like a while loop. Input plus plus. Go on to the next one. I suppose if you hit okay, and at the end we say if star input equals the empty character, the null character, return false. Hmm. All right, hang on. Let's do some test cases. So let's say input is space space tab new line and then space 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 and then QWERTY. So we want to go. We look here. Yes, that works. Keep going. Keep going. Keep going. Keep going. Blah 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 blah. Now we're done, and new input points to the queue. Okay, that makes sense. What happens if we just start off with the empty string or a whole bunch of spaces and then the null character? I mean, that's basically the same as this. Okay. So this is non-space, and the null character is also non-space, so that should both be handled. And then the only other case is when there's nothing, there's no spaces in front, in which case just leave new input equals input. So maybe we should define is space, int is space. a char, ch, and we want to say return ch equals the space character, or ch equals the new line character, or ch equals the tab character. Okay, so that's is space. So now we can use that here. We can just say is space star input. Okay. Should I have like a flag in flag found space equals false to start off with, and then every time we go through the loop, found space equals true. Ugh, I don't like using flags. And then, I don't know, at the end, we just say found space, return found space. And I guess we need to yeah, so in this case, we got to return false because it does not, there is no space. In this case, we can return true, and in this case, we return true. Yeah. Okay. So this is the only case where you return false, or empty string, you also return false. Okay. While is space input plus plus found space equals true. Return found space, and at the end we need to set new input equals input. Okay. So now we go down here, expect space, pass in input, and this should get updated. If that works, then it's int. Oh, yeah, we can skip the spaces. I think that's okay. Expect space, but that's going to return false on an empty string. So maybe we also need allow space. Allow space, jar pointer, ink, paste, allow space, which doesn't require a space. But okay, if it's at the end of a string, if it's at the end of the file, you don't need a space. So this should actually return true. Like, that's okay. Okay, because end of file is fine. Okay, so if you get to the end of the input, found space or star input equals the null character, right? If the input is at the end, and that's true. If found space was false, because we skipped this, yeah, okay. So I think that'll work now. So now we go over here, I'm gonna say, if you get to int, if input starts with int, and then there's a space, then we're good. Otherwise, otherwise, input equals old input, which resets it all the way back up to like here, effectively. Okay. And then we continue. All right, so let's delete these two. Yank, paste. If this equals void, void, yank, int, and char. Char. I mean, there's probably some way to break these out into like separate functions, which would be good, but whatever. All right, so those are keywords, and then we need to handle identifiers. So let's do if expect ident input ref input, and I guess I've been putting the output parameters here. So this is going to be like token data. Token, maybe? So this is not defined. Let's go up to the top. Actually, there should probably be an out parameter as well. Int out token. So maybe out token. How do I rename this? Rename symbol. Out token type. Sure. Okay, and then we want to add another parameter, which is going to be a char pointer out token. Right? Then down here, we want this to be out token. I guess I don't need to reference it because it's already a pointer. Okay. Return, we want to say star out token type equals token ident. Return and star new input equals input. Okay, so now we just need to write this function. Expect ident. Think. Go up here. Int, which is actually a boolean, but whatever. this needs to be a char pointer pointer. This needs to be a char pointer. And this needs to be a char pointer pointer. This is new input. Okay, expect identifier. I feel like we should get ASCII. Okay, C is letter. Is alpha, right? C type header. C type.h. All right, let's just include it. Pound include C type.h. C type.h for is alpha. We should probably also just use is space. Is space also in here? Yes, is space. Okay. So is space. We're going to delete this. It'll just depend on the library. That's fine. So why is this inside instead of up here? Docs. Examples. Examples. All right. Is alpha. So this is A to Z and A to Z. And then also we want is alnum, right? What the hell is alnum? Alphanumeric. Yeah, okay. Is alpha, is alnum. Is that how you spell it? Is alnum. Is alnum. Yes, okay. So we're gonna go down here. Wait. We're gonna go here, expect ident. So first we need is alpha on input, star input. If is alpha on star input. This is bad code. Then we're gonna say input plus plus. Then we're gonna say if actually while return false is default case, while is alnum star input. And actually I think we want to say or star input equals underscore. I think I actually want this on both. Star input equals underscore. Input plus plus. And then after that, at the very end here, we want return true and new input, star new input equals input at this point, right? I think that's right. Should probably test this. And I think I want my braces here. Okay. Yeah, so just keep munching alphanumeric characters or underscores, right? Okay. These keywords, do I still have keyword? No, I do not. Okay, that's good. And so these are keywords, and this is the identifier. Okay. Ooh, being all fancy with my comments. Okay. Identifier. Probably like the smart thing to be doing here is like grouping these into like 100 blocks. So we do like 100, 101, 102, 103. And then literals are going to be in the 200 block, 200, 201, and then all of these could also be in the 100 block. Honestly, these should probably be before all these. So this can be like 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 200, 201. These are keywords. Keywords. Yeah, this is a little better. Literals. Symbols. Identifier. Whatever. Okay. So 200 block. This will be the 300 block. 300, 301. Oh, and while I'm here, might as well reorder these. 301, 302. Identifier will be 400. Okay. Feeling a little better about that. All of this would be solved if I just had enums, but I'm trying to keep it simple. All right, I would like to test expect ident. So where is main? All the way down here. Expect ident takes an input. My name. No, my variable 1, 2, 3, 4. And then I don't know, blah blah blah. Or we could do like my type main blah blah. New input by reference. Is that all it takes? It also takes char pointer token. Empty input. Reference to token. int result equals this. Printf result equals %d result. New line. We want to say token equals %s token, and input, sorry, new input equals %s new input. All right. What did I get wrong? Non-void function return does not return, wait. Non-void function does not return a value in all control float. Starts with. Oh, interesting. Starts with. Hmm. Starts with. So, what happens if we get to the end here? Return false. Is that the correct thing to do? How could we even get out of this infinite loop? How is that possible? Okay, well, there's actually, yeah, there's no way to get out of this loop except by returning early, so this is like unreachable. Ross would have caught that because it would have said, oh, I see that this is an infinite loop and there's only, the only way to break out is with returns, there's no breaks, so, yeah. Okay, so that's safe. Let's compile again. Okay, so token equals nothing. That's actually not good. So token ought to be equal to my type 1, 2, 3, 4. New input is correct, so that's good. New input is space main blah 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 blah. Result is true. Expect ident. Out token. Oh right, okay, so we never assigned out token before returning true. So star out token equals now this is interesting because I can't insert, I can't use a C string here. Because I can't insert a null character into the input, because that would be modifying the input, and I don't want to do that. So I think I actually just need to like copy this into a buffer. So I need to do like stir copy. Stir and copy. CPY. How does this work? So out token needs to be like owned. So this is like a capital S string in Rust. Ugh. Because I need to allocate. So we need to malloc something here. Is that the solution? Now we should just use a buffer. We should be like up here. We should say char token buffer. Should I do it like this, or should I just allocate some memory? I feel like if I do this, then I have to add this feature where I declare arrays up here, and I'm not sure I want to do that. So I think I would rather just keep this a local variable and pass it in instead of making it a global. So in main, we will say token buff, and we're going to be passing in token buff down here. We will say malloc max token buff times size of char. And that's undefined, so let's define this max token, max ident length, max ident length. Int max ident length will just equal 256 characters. 255, 257. Because it's null terminated. Okay. Oh God. Max ident length. So this is uninitialized memory. If we want, we could do, all right, now I need to look up stir copy. C stir copy. And I want like stir n copy because I want to be safe. Stir n copy, C++ reference. I don't know. E and CPP reference. This is what I want. Okay. Stir n copy. Copies at most count. So where's count? Count is the third parameter. This is defined in string.h. So we gotta go up here. We gotta go pound include string.h for stir n copy cpy. Stir n cpy. Stir n cpy. Token buff. And we're going to do stir n cpy. Destination source. Destination is going to be token buff. source is going to be this thing, empty token. And max, okay, count is going to be copies at most count characters of the character array, including the terminating null character. To the character array pointed by dest. Okay. Stir and copy S. I assume S is for safe. Should I be using this? The function does not continue writing zeros into the destination array to pad up to count. It stops after writing the terminating null character. If there was no null in the source, it writes one at that and then stops. Okay, cool. Also, the following errors are detected at runtime and call a currently installed constraint handler if either of those are a null pointer. Okay, well, okay, stir and copy S. Well, stir and copy S. It's just, you can like feel the strata of like C vulnerabilities, the N and the S. This function has been through so much. Okay. So I now need to provide a length, which is going to be 1, 2. Do I really have to count this out? Oh, nice, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, what are you complaining? Too few arguments? Destination size. Oh, okay. So the destination size is max ident length. Oh, nice. Okay. Yeah, it is a better function. So we're literally just passing in like pointer and length, pointer and length. So yeah, we're back to C, or we're back to Rust. Cool. Okay. So we've malloced token buff. So now we need to go into expect ident, and we can do stir and copy cpy underscore s. All right. Destination. Destination is going to be into star out token. The destination size is going to be max ident length. The source is going to be from old input, which I need to define. Char pointer old input equals input. And the length of stuff we need to copy over is, oh god. Maybe I should have been using int I 0. I plus plus equals input plus I. That many items over. Okay, I'm a little worried that the null character is going to be weird. Copy into out token, which has this many bytes. This thing, which is old input, but only take the first I bytes, and return true. Okay. All right. Pointer char. Where is this? Oh, okay. Let's try it again. Okay, that seems to be working. Oops. So result is 1, so true. Token is my type 1, 2, 3, 4, and it looks like, yeah, it did have a null terminator because otherwise printf prints it and expects a null terminator. And then new input equals that. Yeah, okay, so that works. Let's try it with something that's not, it doesn't conform to that. So like a number. Let's try this. Empty token, empty input, new input equals empty input. Ah, okay, so in this case, expect ident, we do need to set new input, star new input equals old input. Is that a problem with like other things, like expect space? I don't think it's a problem there. Starts with, this is unreachable. I don't think it's a problem there either. Okay. Let's try it again. New input equals, yeah, the original input. Empty token. Yes. All right. So we're reusing this token buffer each time we call Lex. Okay, so let's try calling Lex now. My underscore type 1, 2, 3, 4. Lex, and we pass in token buffer. All right, alpha token type, alpha token. So I need this to be out token type, out token type, and this is result. So we don't need anything because it returns void, and result is not defined. Token is this. Token type equals %d. Out token type. So, all right, we should expect this to be an identifier because it starts with an identifier. So what is the 400 is for identifier? Yeah, okay. So we should expect to see identifier. Token type 400, the token is this, and the input is that. Yeah, all right, so that's working. Cool. So we've got identifier. Let me commit this right now. Working on Lex. Okay. Expect ident. Yeah. All right. So we've got to do all the keywords above the identifiers. Yeah. It would be nice to like extract this into its own function. It's just gonna have like a bunch of ugly. It's gonna have a bunch of ugly parameters and stuff. All right, I have to do closure analysis on this effectively in order to extract it properly. So we're gonna need input. We're gonna need this expected keyword and the expected token type. We're gonna need old input and new input. And we're gonna need this. All right, so let me just write this. Let me copy this. Yank. Expect keyword. And paste this in. All right, so we need char pointer input. We need expected char pointer expected keyword. We need an int expected token type. We need out token type, which is int pointer out token typ. We need a char pointer new input. We need old input, which is a char pointer old input. Okay, instead of this is going to be expected token type. And instead of this is going to be expected keyword. Now I need a comma. Can I break this up? Auto formatter, please. This is ugly. Doesn't like it. All right. Okay. Expect keyword. And I'm going to return true, and here we're going to return false. So now this function can fit inside of an if expression. And we should be able to say if expect keyword okay, I already see a problem. Take a reference. I'm going to take a reference, but it's actually an immutable reference. And then it's actually a mutable and immutable reference simultaneously. Ugh. What's next? Expect a keyword char. Token char. Output token type is going to be out token type. Why is this star? Why is this a pointer? Output. Oh, right, because that's a parameter. Oh God, this is complicated. The new input is actually also going to be input. And the old input is going to be old input. Jeez. If that's true, return. Because we found a match. Jeez. Yikes. Okay. But now I can just copy paste these. Okay, so that's char. This is going to be int. Toke int. Void. Void. Oops. Void. Oh, this is tedious. All right, let me comment these two out. Actually, all three of these. And let's see if it still works. It does not like this. Incompatible. Okay, I have like type errors. Okay, okay, input. It's like that. This is probably also incompatible. Expect space. So this should be, oh God, that input. That new input, but that's a char pointer. Uh, star and star. I think that's correct. Star and that. Non-void. Okay, this is expect keyword. Oh, right. Okay, if it doesn't start with expect keyword, return false. Okay, nothing's crashing. We gotta test this out though. So void empty token 302. What is 302? It should be void. 302 is void. Yep. Okay, 300 is int. Um, 300 is int. 300 is int. New input is empty input. Okay, so that's a problem. Mm. New input is empty input. So, okay, I made a mistake somewhere. Expect keyword. I'm pretty sure I made a mistake in here. Probably here. Star input equals old input. Is that all we need? Oh, new input. La, 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 la. I gotta take a break. How do I take a break? Um, mm, I have no idea what's going on. We will close this. I'm going to turn off the mic. I'll be back. I gotta use the bathroom. Hello. Okay, I'm back. I have some coffee. All right. This function signature is kind of garbage. We're passing input as a mutable string. Like this is the string part. This is the string part. This is like the mutable part. It's like the out parameter part. Um, expected keyword, that makes sense. Expected token type, that makes sense. Out token type, that makes sense. New input. So if this is mutable, then why do we need new input? We should be able to get away with deleting that and just mutating input. So instead of new input, let's just say input equals input. So, all right, we don't need that. Star input equals old input. Yeah. And same here. Star input equals old input. Okay. Now I gotta fix where it's being used, which is down here. Did I delete old input from the... No, I did not. Okay. So let's get... Wait. Yeah, I deleted one of these. Okay, why is it not yelling at me down here? I should be able to get rid of these. Delete, delete, delete. All right, compiler. Okay. At least it compiles. It's going to be empty. That's fine. The new input should be space main blah 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 blah. Maybe I should jar pointer input equals int main. So formatting and like start that. Okay. Yeah, still the same problem. Okay, so we got to track down why, we got to figure out why Lex is not changing new input. New input is here. Why is it not updating new input? And I believe it works if it's like some custom identifier. I think if it's a custom identifier, yeah, new input works. But if it's a keyword, like void, it doesn't update. It doesn't update new input. Okay, so what's going on? This is identifier, yeah. What is going on? Input is is a character pointer. We're referencing it, which makes it a character pointer pointer, which is what expect keyword expects. So that should allow input to be updated. All right, now let's go to expect keyword. Where is input changed? Does starts with change input? Yes, it does. We pass it in here, so that could update it. We also pass it in here, and that could update it. Okay, and we set out token type return true. So maybe one of these does not update it. Because this is the branch we take. Like, this is int, this is int token. So it starts with int, and then expect a space afterwards. Then the output token type is expected one, that makes sense, and then return true. And we're assuming that input is now pointing to like the place after the space. After the space. So it must be the case that either, okay, if this returns false, it must be the case that both of these functions are not advancing input. Either that or like somehow this is not getting back to, this is not advancing input down there. This is so confusing. Input equals old input, new input equals input. That's what we're missing. Okay. Right, because the out parameter for, we have an out parameter in Lex, new input. All right. So that's what's not being updated. So actually, we don't need this to be a pointer pointer. We just need to pass in new input. New input. New input, which is sort of what I had before. We don't need, this can be immutable because we're going to modify it like inside of expect keyword. So this can be immutable, which means we can just pass these in. Starts with, yeah, that's immutable. That's immutable. Get rid of all of these. So this should actually, okay, and we do need char pointer because it's an out parameter, new input. And input, this is going to be new input equals old input. And here we need new input equals input. And we also need this. Yeah. Okay. Let's see if that fixes it. All right, so we got some problems here. Oh, right. So since we need to update this, Yeah, this is interesting. So we're mutating internally, we're inside this function, we're mutating input. Yeah, so we need to give, starts with permission to mutate input. We need to give expect space permission to mutate input down here. And then we're about to return, so we got to set the out parameter, which is new input. And we've been mutating internally input, so we set that there. This is, if this doesn't work, we also got to set new input to old input to like reset it. And down here, same deal. Okay. Let's try this again. Okay, yeah, that worked. So new input equals main, blah, 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 blah. All right, we detected int or void. I forget what the example was. Void, yeah. Okay, so now I can delete these, and we have we've sort of broken the keyword identification out into a function, so that's nice. Okay. So now we can do keywords. That's going to make adding keywords a lot easier. I feel like C doesn't really have a whole lot of keywords. It has like void, and I guess you're not allowed to override like int and char because they're so fundamental. Struct, enum. Yeah, that's weird. There aren't a lot of keywords. A return. Oh, if, while. Yeah, those are okay. But let's not worry about those right now. I basically just want to be able to do hello world. I want to be able to parse hello world and like print it back out. So I guess that's my goal right now. Okay. So I think the next thing we need to do is literals, string literals and int literals. String literals and int literals. String literals are going to be annoying. Let's do them. String literals. Break. We're going to commit first. Break. Keyword lexing into its own function. All right. Let's do string literal. How do you lex a string literal? And a string literal, what's the maximum size that a string literal could be? Hmm. I feel like we should be mallocing. Okay. So a string literal could be quite large. I mean, realistically, it's not going to be that big. But we should probably allow for it to be big, just in case. So I think instead of having a buffer for the token down here being external, I think, and then inside of Lex in expect ident, we like stir and copy s into that buffer. I think what we should do is at this point malloc a new string. So this is effectively like capital S string new in Rust, and we're going to return via out parameter. Via out parameter, we're going to return like a malloc string because we're going to need to keep these around anyway. Which means I'm going to have to copy it out of the buffer into a new malloc place in any case. So we might as well just do the malloc here. So jar pointer, it's an out parameter, out ident, and out token. Let's not call it that. Let's call it out ident. We're going to say malloc. And out ident star out ident equals malloc. How big of a buffer do we need? I believe I is the size of the buffer we need. Yeah, the input is I. Yeah. Okay. Then we're going to into star out ident copy. Okay, and its size is I. From the old input, the first I bytes. Okay. Expect ident. Find all references down here. Okay. Expect ident. Tell me the signature again. Out ident. So this goes away. Out token. We can still use this. This is a pointer, and this needs a pointer. Yeah, so it's going to assign in there. Token. Token is just going to be empty token for now. It'll be a static string. Okay. Oh dear, what's going on with this? Use of undeclared identifier token buff. This ought to still be working, but we're not going to be able to see this, so let's do a custom identifier. Or that way it's actually testing. Ugh! Debug assertion failed. Buffer is too small. Oh, wow. So I was writing out of bounds and it gave me a runtime error. That's nice. I did not know it did that. Thank you, Microsoft Visual C++ Runtime Library. Okay, so that's like effectively a seg vault. That's really nice. So I'm probably writing. I probably need an extra. Where was this? The malloc. We probably need like +1 and 1 for the /0 for the null byte. And I believe stir and copy s. We should go back over here. Stir and copy s. Stops after writing the terminating null character. Yeah, so it is going to write a terminating null character. If there was no null in source, it writes 1 at destination count and then stops. Yeah, okay, cool. So it adds the null terminator on my behalf, which is nice. All right, let's try it again. Still a problem. Buffer is too small. Retry. I don't know what retry does. Malloc. Stir and copy s. Let's just allocate a ton of memory. See if that solves it. Is this where the problem is? No. Okay, abort. So we're writing to a buffer that's too small somewhere. All right, expect ident. If the word, if the identifier is cat, C-A-T, and then there's a space. Oh, that's a good point. We're gonna add. No, we're not. Okay. Okay, if it's cat, is input 0 an alphabetic character? Yes. Okay, so we go in here. Now I is 1. Is it alphanumeric? A. Yes. I++. Go back up. Is it alphanumeric? T. Yes. And then space, I guess. Is it alphanumeric? Whoa. Is it alphanumeric or underscore? No. So skip the plus plus. Is now 2. Oh. Input plus 2. Should I like I++ this right here? Hang on, I gotta do this again. All right, CAT space, C, 0, 1, A, 2, T, 3, okay, 3, space, so then we break out a loop. Okay, so I is 3. There are 3 characters in the string, yes. Okay, and input plus I. Oh, this is actually, a better way to write this is like this. That's a lot more clear. Reference, sorry. Reference. Okay, so I'm pretty sure that's correct. We malloc 3 plus an extra 1. Yeah, that makes 100% sense. And then into out ident, which has, oh right, which has room for I plus 1 characters. Copy the first I characters from old input. Okay, I think that's the problem. There we go. 1, 2, 3, is that what I said? Yeah. Blah, 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 1, 2, 3, yeah. Okay. Cool. Okay. Fix bug with no, we're actually moving to make what was this function called? Make ident return string via out parameter owned string via out parameter. Okay. Hi.
What do you think of the shading?
Looks good.
Feels good. Feels smooth.
Okay. I mean, honestly, it would be nice to do all these special characters in the same way as this. So let's quickly refactor. Int expect symbol okay char pointer char pointer input char pointer expected symbol int pointer just int expected token type int int pointer is an out parameter out took type char pointer new input. Oh wow, I think I don't even have to change it. And we do need to return an int, so return true, otherwise return false. Expect symbol. If expect symbol input expected symbol pound token pound out took type new input then return. Okay, let's see if this works. Let's go down to my test. Let's test this first, see that it does the same thing. Yes, and then if we had pound, I'm gonna do the same thing. No. New input, output type. Expect symbol. Cold. Expect symbol. So somehow it's not returning true here. If input starts with, oh, right. Forgot to use these. Expected symbol. Expected symbol. And this is expected token type. Okay. £106 should be pound. 106 pound. 106 is pound, yes. Empty token, and we chopped off the pound. Yeah, okay. So now we can redo all these using this better method. Ink. All right. Open paren, close paren. Open paren. Open paren. Close paren. Close paren. Open bracket. Open brace. Close brace. Close brace. Open bracket. Close bracket. Pound. Pound, semicolon, semi equals equal star and that's it. I mean, I guess I should add comma. 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 110. Okay. Refactor symbol lexicon. All right. Does this still work? I believe so. What I would like to do is run through a loop. Void lex all input char pointer input. We're just gonna write a loop while, I don't know, true. We're gonna say lex input output token type. Probably need all these. Paste output token type. Type. This needs to be a pointer, so reference it, please. Out token. Which is going to be reference to token, and the new input is going to be a reference to input. And this doesn't return anything, does it? No. Okay. Maybe it should. Maybe it should return, like, if it's at the end of the file. So let's go to the definition of lex. Let's change this to int. I really should just have bool. Pound include standard bool. True, false, bool. Oh, that's nice. It automatically did that. That's cool. All right, let's get rid of these. This is just stupid. Int starts with, so this is actually bool. Basically, anytime I say int, I mean bool. Symbol bool. Expect keyword bool. Lex bool. Returns true if at end of input. False otherwise. Okay. So, I guess we just if return true, we're at the end of the input. Okay. I mean, maybe this should actually, I should chomp through some white space first. Chomp white space. Chomp white space. Char pointer input and char pointer new input. I already have like starts with expect space. Chomp white space. Okay. Can I make this a little smaller? Hang on. Pause. Getting a phone call. Okay, let's see. So we need to write chomp white space. So what does expect space do? It's really, chomp white space is really more of a allow white space. Allow white space. So let's call it that, allow white space. Well, let's say it returns true if at end of file of input. Okay, so if star input equals the new, the 0 character, then we're just going to set new input star new input equals input and return true. Otherwise, expect space input new input and return false. We're not at the end of the input, although we will be at the end of this. So maybe we should do this first. Disregard the result. Am I allowed to do that in C? I think they don't like that. Okay, we can actually just say return. that. So just expect a space. If you don't get a space, if there's like, expect a space. If you don't get a space, like this will return false, but we don't care. We've updated the input, right? Even if there's nothing, we still update the input. And then we just say, look, is the input the empty string? And actually, this should be new input. Ooh, yikes. Is the new input the empty string? Allow white space. Okay. So where was I doing? That was up here. Instead of chomp white space, we went allow white space if allow white space is true, we're at the end of the input. And we're going to return. We need to say new input equals input. We're going to return true. Return false, false, false. This is annoying. Return false for identifier. And then if it's like nothing, doesn't really matter because we're exiting. Okay. So now we go in here and we keep doing this while it's not true. So maybe that should actually be return false if at end of input, return true otherwise. Okay, now I gotta go through and return the opposite. False, true, 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 true. Okay. So while you got a lexeme, keep going. Printf, oh, not Rust. Got lexeme token %d I don't know. %s, the token is going to be the out token type and the token, right? So sometimes the token is going to be nonsense. I guess we could just say it's actually always going to be nonsense unless it is. It's always going to be nonsense unless it's a keyword. If out token type equals token key ident, then end of input. Okay, so now for testing purposes, I'm going to keep this around. But usually I just want lex all input. Okay, we're getting some warnings, and I trust the warnings. Comparing a pointer to a null constant character, did you mean to compare it to null? Ooh, okay. Where is this? New input. Yeah, we need an extra star there. Thank you. Let's try it again. Yeah, I think this is working. So hash include my func. Okay, I don't have like a nice way to display like what these are called, so I just have to look them up, which whatever. I don't want to add arrays right now, so that's the only thing. I could just throw these into array, like I know how to do this, it's just I don't want to add arrays to do this because I already have enough complicated stuff. All right. Ugh. So this is a functioning lexer, right? Okay, so include is actually a keyword. That's a good point. Include is a keyword. Int took include equals 303. And now we need to go down here. We need to go to expect keyword, yank, include. Okay. 400, 303, yeah, it's include. Yep. Okay. End of input. Yeah, so this is working great. All right. So add lex all input function. Cool. So we now basically have a lexer. Is there anything it doesn't lex? It doesn't know about comments. which is kind of a problem. It knows about all that. It collects all this. It could do all that. It could do all of this. You do this. It doesn't know while and if and return. So those are some keywords I should add. It also can't do number literals, string literals, character literals. Okay. Well, while I'm adding keywords, we might as well do the easy ones. Toke return equals 304. Token if 305 else 306 while 307 for 308 return if else while for break 309 continue, why not, continue 310. Okay, if else while for break continue. Let's add some more keywords. Okay, return if else while for break continue. Look at that. You can get the number right. Okay. I have bool, right? No, I do not. Okay, let's add bool. 302. 303, 304, 305, 306, 307, 308, 309, 310, 311. Okay. Bool right after char. I guess true and false should be in here. Int took true. 312. False. 313. True. False. True and false. All right. really trying to keep this simple, and it's kind of getting out of hand a little bit. So we added more keywords. Let's see if bool, my bool equals true. If that part lexes. 400 true. True. True, expect keyword, and it's before identifier. Hmm. What is 108? 108 is equal. Aha, okay, so the problem, oh, also, why is that like that? I think this is actually showing up a couple problems. $100 is open print, yeah. Okay, so that's working. So we're identifying a identifier correctly here, and then we see open paren, close paren. Then 102 is open brace, yeah. Okay, so that part's working. This part seems to not be working. We're identifying the true and then 107. What is 107? 107 is a semicolon, so we are seeing the semicolon, but we are misidentifying true as an identifier. Continue, continue, true, true, false, false. I don't see what's different about this. I think the only difference is that it's immediately terminated by a semicolon. So I need to go to expect keyword, expect space, starts with, so it's not actually space, it's actually non-word characters, what we need. I still don't quite understand why it worked, why it's working for my func. 1, 2, 3. Oh, because it's an identifier already. Yeah, okay. So anytime you have a keyword and then punctuation, it's probably going to break. Okay, expect keyword. So expect space, this should actually be expect non-ident character. Char pointer input, char pointer pointer, new input. Okay. Yank. Paste, we're just going to copy everything over. Found. alnum, while is alnum, while not is alnum. And it's not equal to the null character. Yeah. Found, no, so this is actually, okay, so we want to, okay, hang on. Where am I using this? Expect non-item. Expect space. We're in expect keyword. Expect keyword. Okay. Instead of expect space here, we just need to expect we just need to say if okay, if it starts with the expected keyword, and then if input is not is alnum, if it's not alphanumeric, then we're good. Otherwise, if it is alphanumeric, then the problem is star input is alphanumeric. So old input contain then so expected keyword is a strict subsequence of old input example old input equals JavaScript is a language. Expected keyword equals Java. Okay. Okay. So I think that solves it. Let's see. My bool, and then 312. 312. 3, 1, 2 is true, yeah. Okay. My func 1, 2, 3 and my bool. Yeah, so that should, I think that's working. Okay. So what do we do? I don't know. Fix bug with identifier / keyword overlap. Add more keywords. Okay. Would you like stage all changes? Yes. Okay. All right. What is next? We've got like basically a complete Lexer. No, we do not. We don't have literals. I also want int took char literal. I think I would rather have it called like named like this. Literal int literal char 201 200 202 literal string. Okay. Are there any other types of literals? I'm not doing I'm not gonna do float literals. Floating point numbers suck. I guess like array literals, let's not worry about that at all right now. Anything else? There's like the null pointer. I'm not too worried about that. Okay, let's do integer literals. Definitely gonna need that. Max ident length, I don't need that at all anymore. Expect space, allow white space. Let's do boolean expect. I really, everywhere I'm saying expect, I actually mean lex, right? Lex a int literal. Lex literal int. Literally. All right. So we want char pointer input, char pointer new input. Oh, nice. Autocorrects that. And we want the number. We can just throw it in the out token. Char pointer out token. Okay. So is oh god. Digit. Where is digit defined? C is digit. C++.com. I don't like this either. Where is encpp reference? I should just be searching up here in ctype.h. So I wanted to clear that up here just so that we're ctype.h is digit. So, bool digit found equals false. while is digit of star input what is going on? Too few arguments? Is digit. Is digit. What? What is the problem? Too few arguments in the function call? Restart the IntelliSense. Let's see if that fixes it. Oh, is there an error up here? No, that's fine. Int blah equals 1 to 3. Okay. While this is the case, we want to input plus plus. Oh, and we actually want to int I equals 0, do it like this, because I don't want to do pointer subtraction. I could do it like that, I just don't want to. So input I plus plus, and I suppose this could be a for loop. I'd rather it wasn't though. While is digit. I'm gonna have to parse plus, am I not? Because I used plus here. Ugh. And plus plus. Okay, it's not too bad. Okay, so we're gonna skip until we get something that's not a digit. Then we're gonna malloc out token star equals malloc I plus 1. Need extra space for the null character. Then we're going to do stir and cat cpys. The destination is going to be into out token star out token. Right? Yeah. The size of out token is I plus 1. The source is going to be from old input, which I'm going to save up here. Char pointer old input equals input. And how much do we want to copy? Exactly I bytes. And we're going to return true. Okay. However, if and inside here we want to set digit found equals true. Digit found. Then do all this. Else return false. Oh, we need to update. New input equals input. Oh, actually, since we're doing this, I'm actually not doing. So this is just input. Input plus input I reference. Sorry, actually, new input equals just input. Go back. Yeah. Okay. Okay. If I is greater than 0, we might as well just do it like this. We don't need to keep track of the flags. If input so to handle negatives, do I want to handle negatives? Do I want to handle negatives? Because this is a bit of a problem. And input 0 is not equal to negative. If I is greater than 1, or if I is equal to 1 and the input is not just the dash, then do all this. Okay. This is going to parse just like dash, 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 dash. So I guess what we want to do is actually say input 0 equals dash. I plus plus. That's acceptable. Then we do while if input 0 equals dash dash equals dash, single dash. And I guess you could also do unary plus. I don't need to support unary plus. While is digit blah, 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 then do this. Yeah. Okay, and then this is also okay. Because so what happens if this is false and this is false? Then we're going to get 0, in which case we go in here. Okay. I think that works. Okay, lex literal int. So let's go here. Actually, we should do literals before special symbols, I think. If lex literal int input out token is going to be out token, and means new input is going to be new input. True. Lex, a literal int. Okay. I don't know why this is yellow and this is orange, but okay. Lex, a literal int. And so we're going to store we're just storing the text. We're not converting it to a number yet. We're just mallocing and storing the literal text into there. So, okay. Let's see if I do int my int equals 1, 2, 3, 4. Negative 1, 2, 3, 4. If we can parse that. And we need to go up here and we need to say or out token type equals token literal int. Okay. My func, my int, and then we're getting 108, 108, 107. My int, 108, 108, 107. 108 is equal, so we're getting 2 equals. All right, that's bizarre. Lex, literal int. Why are we getting 2 equal signs? Oh, we're not, hang on. Lex literal int, out token, we also need out token type. Int pointer, out token type. Out token type star equals token literal, oops, token literal int. Let's try that. Okay, we're getting some kind of error. Oh, right, I didn't update this down here, right here. Out token type right here. Out token TYP. Yeah, all right, I think that's working. I guess I don't need keywords for those two. That's fine. Keywords true and false, that's fine. Because I could do it as literals in the same fashion, but All right, and does it work for positive numbers? Let's test this. Yeah, looks like it does. All right. So I think okay, I need strings and characters. So let's update this and say lex ints. And then we need to do lex lex literal int, lex literal char, input out token type out token, and new input true. Okay, and let's just add this in, but comment it out. It's gonna be lex literal string, lex literal char. All right, where is lex literal int? Here, and we're going to do bool lex literal char. I'm going to copy the signature up here. Okay, so first we need to say int I equals 0. We're going to say we're going to do if if input I equals the character, single quote. Maybe we should set new star new input equals input right up here. And then we could be like not equals return false. Then if oh dear, we're doing I++. No, we're not doing I++. The backslash, we're gonna handle escapes. Then things get a little complicated. Let's not deal with that yet. Input I is not equal to end quote return false. We break out there. But otherwise, I++, and we're going to say star new input equals input I reference took out token type equals took literal char star and out token equals malloc I+1 stir and cpys destination is out token. The size is I+1. The source is input, and we want I things from that input. Return true. Hey, another cat.
She's really good at holding on. So you can sort of like do movements with this one. It does hurt.
Hi, kitty. Let's not repeat last night. Ow!
She is like
Ow!
needle sharp
Ooh!
right now.
Oh. Not even a point to it.
So, how has it been going?
I'm having a good time.
Is there anything you can say about the program that I'm gonna understand?
Yeah, it's a compiler
Okay, a compiler in C.
in C. So the language I'm writing the compiler in is C.
Right. But it's going to compile to a different language, or it's its own language, I guess.
So I'm trying to make a bootstrapped compiler, which means a compiler written in the language that it's defining.
Oh.
So you kind of have to like. It's harder to explain than like if you kind of knew what was going on, but okay. So imagine we're defining JavaScript. Like I'm inventing JavaScript, and I have to write like a compiler for JavaScript.
Why? Remind me what a compiler does.
Because a compiler translates the language you're defining into an existing language.
Right. Okay.
So
what I would do is I would just write a compiler in the existing language. And I would compile my new JavaScript thing into that existing language. So that's what I would
sure. Usually the target language, the existing language, is something low level, like assembly.
Binary.
Yeah. And so you don't want to have to write a compiler in assembly because it's annoying. So usually you would use like a more high level language, like maybe Java or something, to define the compiler.
Okay.
But you could do that. You could write your compiler in assembly and also have your new language compile to assembly. It just so happens that I'm making a compiler where the source language, meaning the language we're defining, the language we're creating the compiler in, and the language we're targeting are all the same language and they're all C.
I mean,
I'm doing,
that doesn't make a lot of sense.
Right. So basically, what I'm doing right now is I'm writing a parser that parses C code into a tree in memory, into like a syntax tree. So it like understands the C code in some sense. It turns just raw text into a tree data structure.
Okay.
Kind of like in English class, you have like the trees. It's like, oh, a sentence is made up of a noun phrase and a verb phrase, those types of trees.
So would this kind of be like there's a for loop, and then inside of the for loop is an if, and inside of the if is a blah, blah, blah.
Yeah. So that's called the syntax tree or the abstract syntax tree. Okay. So right now I'm just making a program that.
And you're writing this in C.
I'm writing it in C. It's a program that takes in C code and builds a tree representation of that C code. Okay, so that's the front end of the compiler, or the first half of the compiler. The second half of the compiler is actually going to do the compilation, where it's going to take this tree and it's going to just basically print it back out as C code. And then it's also going to like call a C compiler on that printed out file and run it. Okay, so like literally it's not doing anything.
Yeah.
But once I have that, then I'll be able to start changing the language in the middle. I'll be able to say, oh, okay, let's add like a new keyword to
as
C.
You've got it broken down into a tree before you print it out. Then, while you've got it in this like metabolized form or whatever, you go in and say like, okay, now replace the word if with
Um,
blarg in another
yeah,
language. By blarg, I mean if
yeah.
or whatever.
It's more like let's add a new construct in C, or like so I'll be modifying like the parser in the front part. I'll be saying I don't know, let's add like a match keyword, like match statements, um, to the language. So C does not have match statements, but let's add those in. Or let's change how functions are defined. So I want to say instead of how you usually define functions in C, I want to start it with the fn keyword. You could do that. And then you just sort of throw away that fn keyword in the middle. And in the middle, it's just this tree form, which just represents the data. And in the back half, it knows how to translate that tree just into C. So it's the nice thing is it makes it very easy to bootstrap because if I can get the compiler to understand its own source code, then I could just go in and like start changing the source code um, into like a new language. Uh, Somehow it'll work out.
Okay, I mean, you're kind of losing me there.
Yeah, I'm losing myself.
Well, so wait, so is it kind of like if there was like a Spanish to English translator and they
Okay.
hear something in Spanish and then they sort of like hear it and then they kind of have to like break it down into like fundamental parts in order to paraphrase it in English because it's not a word for word translation. So they have to like
Yeah.
understand it more
Mm,
fundamentally.
mm.
So that's like breaking it down into a tree and then once you've got it in a tree, you can sort of build back up in a different language.
Yeah. So maybe like that example, maybe the analogous example with like human language translation would be like if I'm a translator from English to Spanish and I take like a poem in English and I translate it into Spanish and write it down. And then like a week later I come back and I see that Spanish poem that I wrote down, which was translated from English, and then I translate it back to English. And I mean, I don't know. I guess if you actually did that, it's possible you wouldn't get the exact same English as you started out with because you might make different decisions.
Mm-hmm.
Um, or it might be the same. Yeah, okay. So say it's like that. Um, and like ahead of time, this poem is like a poem that you and I write, and you're my brother.
Mm-hmm.
So we have like a bunch of inside jokes.
Right.
And so um, we have like a slightly different version of English than the rest of English speakers because we have some inside jokes.
True.
So if your poem contained one of those inside jokes and I had to translate it into Spanish, I'd probably need to like translate that inside joke in some way. And when I need to translate that back into English for like a wider audience from Spanish, maybe I could do a more direct translation from the Spanish to the English, but it would keep that like change. So I don't know what's an inside joke that we
Yeah.
have.
I'm stressing out now because I can't think of any. These floors bite.
These floors bite.
Okay.
Yeah, so your poem is like these floors bite. I'm having a terrible day. That's your poem.
Okay.
And then we translate that into Spanish, and the Spanish equivalent is like my feet hurt, or I don't know. Like this house is weird. This house is weird. I'm having a terrible day.
Okay.
That's the translation. And so when we translate the Spanish back into English, then it just sounds like that. So our idiom is gone,
Okay.
but it has like sort of an equivalent in regular English.
An equivalent which is now more available to people outside of our in group.
Yeah.
And so, like, the reason why you're doing this big translation thing is to make it more available to people outside of our in group.
Yeah.
Huh.
So I guess actually in this program, there's no Spanish translation step. It's just English to English, and it's just, but it's like our, you know, people in you and I's club, our English to general English
Hmm.
translation.
Well, it's kind of like So when you translate our poem, These Floors Bite, I'm Having a Terrible Day, you sort of go like, okay, as you translate it into Spanish, you kind of have to like break it down fundamentally,
Uh,
and then you turn it into Spanish. But you
yeah.
just like pause that process halfway, and you're like, whoa, wait, I don't even have to translate it into Spanish. I'm already good now.
Yeah.
I've inside of my mind, I've broken it down fundamentally.
Yeah.
Now I can just turn it back into English.
Yeah.
Well, okay. I don't quite understand how any of this has to do with programming.
Well, it's languages.
Well, yeah, but what is like available to a wider audience? That's not in our industry.
Available to a wider audience means, in this context, means everybody has a C compiler on their computer.
Okay.
Um, Nobody, including myself right now, has
Compiler for your language.
a compiler for Parasitic C, which is what I'm calling this language that I'm going to define. Once I'm done with the compiler, I will have, and anyone I share this with will have a Parasitic C compiler. Um, and so in order to run any of the code that you write in Parasitic C, you will need a Parasitic C compiler and also a regular C compiler, because it translates, the Parasitic C compiler translates Parasitic C into C, and then you'll also need a C compiler to translate C into assembly so you can run it.
Well,
So the wider audience is anyone who has
a C compiler.
Yeah.
But so wait, why wouldn't you just write in C? You're writing like, okay, I'm writing a program. It's going to take in a bunch of text and it's going to turn it into C code and then compile it.
It's going to turn it into C code and then compile it.
So like this is the compiler for Parasitic C.
Okay.
And then you just have to say like, okay, when in this block of text that you're going to get, when you see the word blarg, compile that to in C, if then or whatever.
Okay.
Like why wouldn't you just do that? Like that seems to be the.
Oh, yeah. Why wouldn't I just completely invent a brand new language, right?
But you're not? I thought you were.
Why wouldn't I just make up like a completely different language to C, and that's my new language, right?
What the fuck are you making if not a different language?
Yeah, eventually it's going to be like that. But to start off, I want to keep it as close to C, actually identical to C, to start off with. And the reason for that is I want to get to a self-hosted compiler as soon as possible. So
you can start testing it.
I honestly don't even know what I'm going to do with it because I've never interacted with like self-hosted compilers really. And you kind of just have to like sit down and think about like, all right, what the hell am I actually doing? Whenever you like call the compiler on itself, you're like, okay, what does this mean? And then you think about it for a bit, and you're like, okay, I understand what's happening. But a self-hosted compiler is a compiler written in the language that it defines.
Right. Whereas what I suggested is a language written in
in
the
a
language
different language.
In the target language.
Or just a different language, yeah.
Right, okay.
So I want to.
And you want to do it in your own language because writing in your own language is easier.
Eventually it'll be easier. So like I was making a language over the summer that was kind of just like a brand new language, had like new. I mean, it's pretty similar to like Ruby or JavaScript, but and I was like, oh, I want to get this to the stage where I could be self-hosted, so I could rewrite the compiler in the new language. But like that takes a lot of work.
And you didn't start with that in mind.
And I didn't start with it in mind. I was just trying to make a language. So the point of this is I really want to get to self-hosted as quickly as possible. And then we can start like adding features to C and turn it into like its own language.
Okay.
So it's called Parasitic C because it's going to eat C from the inside out.
Yeah. Well, and you gotta like learn the rules before you break the rules. Or like be able to do what they're doing before you can do better than what they're doing.
Yeah, I guess.
Okay. Well, I feel like I understand more than I did. And it sounds cool. because it sounds like something that shouldn't be able to work.
The trick with self-hosting compilers is, or bootstrapped compilers, I think they're called. Like pull yourself up by your bootstraps, because it's like, how is this possible? Is you have like, so imagine I like type away and I finally get the C compiler working, or I don't know. Let's go back to like the JavaScript and the C example. So I'm defining JavaScript, and I'm writing the compiler in C, and JavaScript is going to be compiled to assembly.
Sorry, just say that again.
Okay, so I'm writing a compiler in C. It's for this brand new language I invented called JavaScript, and it's going to take JavaScript to assembly. This is not how JavaScript actually works, but whatever.
Okay.
I'm writing the compiler in C. So, and I want to eventually make it self-hosted.
Okay.
So I work and work and work, and finally I defined all of JavaScript in C via the C compiler. So now I have that compiler. It's written in C, and it takes JavaScript source code, translates it into assembly.
Mm-hmm.
Okay. Now I hit the compile button on my compiler. So C source code cannot be run on a computer. You have to compile it, right? To assembly. Okay. So I have to compile my compiler.
Right.
In order for it to actually do anything.
Sure.
So I use GCC, which is the C compiler. I use GCC, I say GCC mycompiler.c, and now I have an executable, which is a whole bunch of ones and zeros, and the computer natively knows how to run these ones and zeros as the program. Okay, so I have this thing, which is an executable. Then I put this on a shelf. Then I go and I go into JavaScript. I open mycompiler.java or .js. Sorry. I write a JavaScript file, and I work and work and work, and I redefine the entire compiler. I basically translate my C code into JavaScript.
Okay.
Like line by line, I just say, okay, instead of void main, I write function main in JavaScript.
Okay.
And I rewrite my entire compiler in JavaScript.
So now you've got a compiler on a shelf that can turn C into assembly.
I've got a compiler on the shelf that can turn JavaScript into assembly.
What? No, you don't. Because that was the GCC compiler or whatever, right?
No, okay.
Wait. No, yeah, you're right. Okay. You compiled your compiler, so what's on the shelf can compile.
But the only thing that this program can do is take JavaScript to assembly. Okay?
To assembly or to C?
To assembly.
Okay. All right.
Okay, and it's just like a program.
And then in your text file here, you have
I have JavaScript source code, yeah.
And this, before you turned it into JavaScript, it was C?
Before I turned it into Java. Oh, I'm going to basically rewrite all the C code I had in JavaScript.
The C code for the compiler?
Okay. In JavaScript. So now this JavaScript file defines a program that takes in JavaScript code and spits out assembly code. Okay?
Yeah, and it's written in JavaScript.
And it's written in JavaScript. Now I take the thing off the shelf, my executable, which is a whole bunch of ones and zeros.
Whoa.
It's a program that knows how to take in JavaScript and spit out assembly. And I take my JavaScript compiler, my compiler written in JavaScript, and I feed it in, and now I get a new executable.
Yeah, and so this is in assembly,
and
I mean it's in assembly, but it's also kind of in JavaScript.
But it's defined by JavaScript, yeah.
And it turns JavaScript into assembly.
Assembly, yeah.
And so whenever you want to edit it, you can just
Whenever I want to add a new feature or something,
you can edit it in JavaScript.
I can edit it in JavaScript, and then I just have to recompile that new JavaScript source code using just like the previous version.
Oh man.
Yeah. That was cool.
That's kind of a mindfuck.
Yeah.
But I guess it works.
Yeah.
Okay. So it is kind of like a match that lights a fire, where like you need something.
Yeah, like dominoes.
Yeah, you need something to start it,
Mm-hmm.
but then it kind of keeps going on its own.
Yeah.
And if you were to like, if the fire was to go out and like, if like you okay, I'm gonna edit my compiler, I'm gonna go into the JavaScript and change some things, and then you compile that one, and you're like, great, I've got my new compiler. Let me just throw away the old one.
Uh-huh.
But your change like broke it, and now it like doesn't work anymore. You would be like up a creek without a paddle, right? Like you'd be like, oh shit,
I
the
think
fire
so,
went
yeah.
out.
Yeah. Yeah, so like say you do that process. So every time you add a new feature to the JavaScript to the compiler written in JavaScript, you have to recompile it using the previous version of the compiler.
Or any of the previous versions of the compiler, right?
Maybe, but maybe you've started using like some of the new features you've been adding, and
Yeah.
so you probably should use the most recent version of the compiler.
Okay.
So say you're on like the 100th version,
Okay.
and yeah, your hard drive, I don't know, gets hit by a cosmic ray and it deletes the first 99 versions. Um,
So now
but
you
not the most
only
recent.
have the version.
Yeah, you have this executable, which is just a bunch of ones and zeros. It's a program that knows how to take JavaScript or your JavaScript language into assembly.
And that's like the 99th version.
Uh-huh. Um, and then you're like, hey, I want to share this with the world. Um, you can send the ones and zeros to anyone, and as long as their computer knows how to run those ones and zeros
To compile
things, it'll work. Um, but the problem is, if I did that on my computer, the ones and zeros would be like kind of different for anyone who doesn't have exactly the same type of computer as me.
What?
Yeah, because this computer has a certain architecture, which is like an assembly language family.
Okay.
Um, and this computer has special hardware, specific hardware.
So are you saying like they would have to go through all 100 things from the ground up and like do the
Yeah,
compile?
yeah,
What?
yeah. So if they don't have exactly my computer, they might have to do that. Yeah. There's like,
And because you could send them your JavaScript.txt file, which
mhm,
defines it, but
mhm,
how are you going to compile
right.
it?
So I think what,
So they would have to start in C
yeah,
because they
yeah,
have C.
right. Theoretically, I think usually what happens is to avoid that, because right, it's like insane. Like I think Rust, which is only 6 years old at this point or something like this, um, has probably like 100 or 200 versions of the compiler by now, something like this. And probably more than that since like becoming self-hosted. But now what they do is the compiler is smart enough to know how to compile, to cross-compile for other architectures, for other computers.
So in the quote unquote JavaScript,
in Rust in this example.
right? Because it's self-hosted.
Rust is self-hosted, yeah.
So in the Rust compiler file for the compiler, it says like it's got a big if statement. Where it's like if you're on a Mac, go this way. If you're on a Windows, go this way.
Yeah.
If you're on Windows, compile it like this.
Yeah. So basically, it knows how to generate all different types of assembly. Yeah.
But okay, so then if you want to send your assembly to someone else, you would need to like before you assemble or before you compile your code, you would say like, "Hey, psst, compiler, can you compile this as if it was on a Windows?"
Right.
Because my friend over here has a Windows computer. I know I'm not on a Windows, but for their sake, can you do that?
Yeah.
Okay.
And like some people are like concerned. They're like, "Oh, but we can't. We've lost like the ability to bootstrap or whatever." Um, I think like if certain tools like become deprecated or like lose support for some feature, then like, oh, we were depending on this tool to compile version 3 to version 4, so now we've lost like a link in the chain, so we gotta like do archaeology and find like the old version of this tool or something. So like some people were kind of concerned about that, but Um, Other people were saying like, it doesn't really matter. Like, we don't need to like remember how to get to 2021 from the Stone Age like every single time. We'll
Yeah,
figure it
those are
out.
sort of like doomsday preppers, or it's.
Yeah, a little bit doomsday preppery.
Hmm.
So
Hmm.
anyway, it's interesting. So I want to try playing around with self-hosted stuff. That's why I'm doing this.
Sounds like, you know what it sounds like? It sounds like a Dementor or whatever. Or what's the word? Where it's like a
Servitor?
servitor, where you like create it and then it takes on a life of its own.
Oh.
And it's like, I'm not in control of it anymore. It's self-hosted.
Oh, you are in control of it. And it'd be a lot of work to keep up with. So I want to stop this stream.